Uh, Good morning, everybody. Renil, unmute yourself and tell me. Audible and you can see the screen.
Yes, sir.
Yes, okay. Last class we discussed about the measurement of force and torque. See, in the force is nothing but the gravitational attraction between masses. So usually the force is measured by using the calibrated devices. Standard calibrated devices are available in the market. So from that you can measure the force. The force is classified into two types. Force measurement is classified into two types that can call it as fundamental methods or classification. So here there will be two types. One is a direct comparison, other one is indirect comparison. Or otherwise you can define like this also: direct measurement and indirect measurement. The direct measurement is good example is the unknown grocery is placed on the left side, and the right side you keep the left side you keep the standard dead weight 500 grams, 1 kg, 2 kg, like that. On the right side, the unknown weight of unknown magnitude, that is the weight of the grocery. By adding or removing the groceries in the right pan, you bring the needle to read zero. That is the null balance. So before operating the machine, measuring machine, so you set the instrument to null balance. Null balance means zeros. So for this good example is analytical balance. So you have a diagram here, the analytical balance. Almost all the question paper, you have a question on analytical balance. Here, the symmetry of the beam, and the balance of the weight, unknown magnitude, and the known standard magnitude. You have to bring the beam to the symmetrical condition or symmetry or horizontal condition or 180 degrees. All of you observe here, the left side and right side and the center are placed on triangular sharp edge. Triangular sharp edge. The beam oscillates left side and right side. When the beam come to the standstill condition, that is exactly 180 degrees. That is the measurement. When the needle measures the zero, that is the measurement. Next, come to the point, the indirect comparison or indirect measurement. So here you have two or more translations. Two or more translations. So this good example is electronic weighing machine or electronic speedometer or electronic digital weighing machine. Say, all of you see the weigh bridge, which weighs more than 10 tons or 15 tons or 20 tons or 25 tons or 50 tons. So there they are using electronic weigh bridge. So when the vehicle is placed on the platform, which exerts the force on the bottom lever or the platform, there you have the sensor. Usually sensors are provided with strain gauges. So these strain gauges converts the force into resistance. Resistance is converted into analogous signal, and analogous signal is converted into voltage signal. Again, that voltage signal is converted into digital form. You measure the weight of the vehicle along with the material in terms of kgs or in tons. This is there will be two or more translations are present. So the name itself indicates indirect measurement, that is indirect measurement. Next, come to the point. For this good example is electronic weighing machine. Next, come to the point. Very important. The examination point of view. This is very important. This you have in the examination for 10 months. The question will be like this. The explain briefly with neat sketch multiple lever system or platform. Okay, here there will be lot of levers are present. For that reason, it is called multiple lever system. And also you have a platform. All of you observe here. This is the platform, and there will be a beam. So a beam is graduated in terms of kgs. This is the moving poise weight, and this is the standard poise weight along with the multiple lever system or platform scale. The manufacturer provides the dead weights of 10 kgs, 5 kgs, 20 kgs, and 50 kgs, and more dead weights. You have to fix that weights in the hook provided in the beam of the platform scale. There will be a slot. From that, you can keep the dead weights here. Suppose if you want to measure 43 kgs, so here keep the 2 into 20 kgs. That becomes 40 kgs. And the moving poise weight, you move this pointer should read fifth division or fifth graduation, that indicates 45 kg. Like this, you can measure the unknown magnitude keeping on the platform. So what are the things present here? First, this is the beam, and backside there will be adjustable counterpoise. This is required for making the instrument to read zero, that is null balance, and this end is connected with the tension rod. That one end of the tension rod is connected to a big lever in the bottom, and again this lever is hinged at one point, other end is connected to the tension rod. And again, this lever is connected to one more lever, it is hinged at one point, and the other end is placed on the big lever. So both the lever supports the platform. Both the lever supports the platform. So once again, this is the beam and adjustable counterpiece tension rod, and this tension rod is connected to a big lever. Big lever supports the small lever, which is hinged at one point, other end is supported under big lever. These two levers supports the platform. So when you keep the unknown magnitude on the platform, anywhere on the platform, all of you observe here W1 and W2. That is nothing but W1 plus W2 divided by 2. That will give you the W. That is, if you keep the unknown magnitude anywhere on the platform, that gives you the correct result, correct measurement. That is the advantage. So all of you knew how do you define the force? Force is equal to tension into distance, radial distance. That is R. F equal to T into R. The same way you have small derivation. That is, you measure the force in vertical direction and the radial distance. That will give you the force. Then, if by deriving small derivation using this relationship, we can derive an expression for scale multiplication ratio. Scale multiplication ratio. After that, you have a small derivation force equal to T into R. Next, come to the point, the proving ring. See, when you come to the college, you have to conduct the experiment on universal testing machine. Using universal testing machine, you can conduct the experiment. So the advantage of using universal testing machine is you can load the specimen not in kgs, in tons. Remember, so you can load the specimen in tons. That is possible. So this is the instrument proving ring used for calibrating large measuring devices. So this is the circular ring which is made of rectangular cross-sectional aluminum casting, and there will be two projections are present here, pro- provided here. These two are used to fix the upper and lower projected portion in the upper jaw and lower jaw of the universal testing machine. Say, if you use the universal testing machine continuously for 5 years, 10 years, or 15 years, or 25 years, so you have little problem in the result of the measure. Usually, universal testing machine is used for conducting the tension test, compression test, shear test, and nothing is impossible. You can conduct all the experiment in the universal testing machine. For that reason, it is called universal. The word universal means you can conduct any experiment. Nothing is impossible. You can conduct any type of instrument. If you have any error in the measurement, that can be rectified, removed, or you can set the instrument to make a correct measurement. So here you have two projected portions that is used for fixing the proving ring in the upper jaw and lower jaw of the universal testing machine. And there will be a thread or reed. In the bottom you have the dead weight, and here you have the micrometer. So when you keep this in between the two jaws, if you load the specimen in terms of kgs or in tons, this thread or reed oscillates right side and left side. If this reed coincides with the third division, then you load the specimen in 5 ton. If you remove the load and load the specimen in opposite direction, again this reed in the right side or in the left side with the first division, there will be error in the measurement. So in the universal testing machine, there will be a provision to load the specimen. You can load the specimen hydraulically. Load the specimen hydraulically. If there will be any error in the loading system or hydraulic loading, that can be rectified. Bring the read to zero when the there will be error of five divisions in the read that can be rectified. Bring this thread along with the weight to read zero. Then you can say there is no error in the measurement of tension test or compression test or shear test. Next, come to the point torque measurement. All of you know the vehicles. The vehicle means the engine that may be two-stroke or four-stroke or petrol engine or diesel engine. The power, mechanical power developed by the engine or developed by the system is called torque. Is called torque. You might have seen in the advertisement or in the paper or in the TV. Uh, 150 newtons meter torque developed at 4,500 rpm of the engine. What is actually that is the mechanical energy, mechanical power, which is developed 4,500 RPM, developed at 4,500 RPM, which produces 1,500 newtons or 150 newtons meter. That is at 4,500 RPM. That is the maximum power developed by the engine. Then once again, the torque can be measured using the torque measuring instruments that is called dynamometer. That is called dynamometer. You may have the question in the competitive examination, the name of the torque measuring instrument. Maybe four answers are there. The correct answer is dynamometer. How do you measure? Torque T equal to force F into radius of the reaction arm. Or even you can measure the radial distance in meters and the force in kg meter. T equal to force into R. T equal to F into R. And again, there will be three types of dynamometers are available for measuring torque. One is absorption, second one driving, third one transmission. See, absorption dynamometer, the name itself indicates absorption, which absorbs the energy and gives the result in terms of kg meter or Newton meter. Absorbs the energy and gives the answer in Newton meter or kg meter. The absorption dynamometers are usually used in to conduct on engine as well as in electric motors. Next, driving dynamometer. Driving dynamometer means the engine or motor drives the another engine or another motor. From that we can measure the torque developed by the engine or compressor or pump. Next, come to the point of transmission dynamometer. Usually, the shaft of the engine, shaft of the motor is coupled with the electrical loading or the induction motor or any motor. From that you can measure the torque developed by the motor or engine. The transmission, the name itself indicates to transmit the power from one point to the other point. Next, come to the point, very important examination point of view. This time you have this question. If you don't have a question, if you please write down the question, explain briefly with neat sketch, with neat sketch, absorption, absorption or brony brake or mechanical dynamometer. Put a question mark. List the applications. List the applications. See, all of you, please observe here. All of you seen the brake
lever in the two-wheeler or in the car, when you press the brake lever, what will happen? The brake shoe along with the pad elongates, moves in the outward direction, presses the brake drum and bring the engine to standstill condition or stop the vehicle. In the same way, here you have a lever like this, which is supported on the wooden eyelets. All of you observe here, this is wooden eyelets, and this is the shaft, and the distance from the center of the shaft to the platform scale. The force exerted by this lever can be measured by using the platform scale. You can place 100 kgs, 200 kgs, or 50 kgs, and the distance from the platform scale and the center of the shaft, or that is torque equal to force F into radial distance. That gives you the torque. Next, come to the point, hydraulic dynamometer. The name itself indicates hydraulic. That's nothing but water dynamometer or water brake. So all of you observe here, this is the casing. Here there will be a provision to fill this chamber or housing about to 1/4, 1/2, half, and 3/4, and full. In that, there will be a flywheel. All of you observe here. This is the shaft connected to the motor or connected to the engine, supported by 4 bearings. And the center, you have a flywheel which is immersed in the water. So when you fill this with 1/4 of the water and connect this to the engine, run the engine and measure the speed of the shaft by using tachometer. Use that equation in this equation and find out the BHP. In the same way, fill this housing with half its capacity, 3/4 of its capacity, and full. And note down the speed of the shaft by using tachometer and calculate the torque in terms of kg meter. This is the hydraulic dynamometer or water brake. All of you, please write down the question. Explain briefly with neat sketch. Explain briefly with neat sketch the hydraulic dynamometer or water brake. Water brake. Put a question mark. Water brake. Put a question mark. List the applications. List the applications. Next, come to the point. Another type of dynamometer is the transmission dynamometer. The name itself indicates the power or the mechanical power or the energy developed by the engine is transmitted to other engine or electrical loading system. From that, you can measure the torque. So all of you observe here in the transmission dynamometer. This is coupled with another shaft. This is the input shaft and the output shaft, and they have fixed the strain gauges and they calculate the speed of the transmitted power transmission from the engine or transmission from the turbo machine or the turbine or compressor that can be measured in the other output shaft by using the transmission of power from one point to the other point. This is called transmission dynamometer. Usually, this type of transmission dynamometer is used in workshops and machine shop and large power plants, because you cannot directly measure the speed of the engine or the motor which is coupled to the another shaft. From that you can measure the speed of the shaft. From that you can calculate the torque of the plant, power plant. This is called transmission dynamometer. That name itself indicates transmission, transmit the power from one point to the other point. The other point, you can measure the speed of the shaft by using tachometer. Then you can calculate the torque. So this is the last portion in transmission dynamometer or the torque measuring instruments. So we discussed force measurement and torque measurement. Next class, I will start the other chapter, the pressure, strain, or temperature measurement. Now, I stop at this stage. All of you, please write your name and USN in the chat box. All of you unmute yourself.
Sir.
Pritham, unmute yourself and tell me the answer or
Present,
call.
sir.
Pritham, Rahul
Present, sir.
MT, Sambram, unmute yourself. Rahul,
Present, sir. Rahul MT.
okay. Pronounce your name yourself. Tell me your name one by one. Unmute yourself and tell me your name.
Pratik.
Speak loudly.
Yashwant Kher.
Huh?
Yashwant Kher.
Okay. Next.
Pratik RB.
Okay.
Rahul N.
Siddharth HR.
Okay. Rahul.
Pawan Kumar Devi.
Okay.
Pawan Kumar Devi, sir.
Yes. Okay.
Shashank HR.
Yes. Okay.
Vedavyas. Shashank HR, sir.
Yes. Okay.
Vedavyas.
Anybody
Siddharth
else?
HR.
Okay. Anybody else?
Shashank HR, sir.
Okay. 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 Mark. Okay. Anybody else?
Pratik RB.
Okay.
Sir, Vedavyas ki.
Next. Next. Okay. Now I stop at this stage and I will continue in the next class.